So we've just finished up a few days reviewing right triangle trigonometry. We looked at what it means to solve a right triangle, but really that was just a lot of practice with right triangles, which is SOHCAHTOA. And we looked a little bit at double triangles, so a little bit of problem solving and a little bit of applications as well, where we had to draw diagrams, that kind of thing. Okay, and we're going to come back around to that. We're going to do more applications and more double triangles and that kind of thing, but not for a little bit. Most of you will have seen this, but not all of you. Sine law. And this is when we don't have a right triangle. What do you do when you don't have a right triangle? Well, we have two other formulas. We're going to do one today and one tomorrow, and those are all we need. One of them is sine law, one of them is cosine law. People always ask, what about a tangent law? Well, you could come up with a tangent law, but we don't need it because sine law and cosine law are simpler than any tangent law, and they can find everything. So we just really use those two, okay? And so we're going to do sine law today, and we're going to take a few days to take a look at sine law, take a look at cosine law, and then how to tell when you use one and when you use the other. So we're going to take a whole day just to look at that as well, because that's a big part of this, is figuring out when to use the right one. Um, so a little bit of what I talk about will help you start thinking about recognizing sine law right away, but until we've done both and we start to compare them at the same time, it won't be quite as obvious when you use one and when you use the other. But like I say, in a couple of days, we're going to look at that. Okay, so for both of these formulas, but sine law often even more specifically, we need to think of the angles in a triangle and their corresponding or their opposite sides. So that's the most important thing about sine law, is connecting angles to the side lengths across from them. So again, notice that angle A is across from side length A, and I use a capital A for an angle and a small a for a side length. Whoops. Angle B is across from side length B, and angle C is across from side length C. So that's not a coincidence, that's on purpose. We have talked about that. There are two versions of sine law, and I'm going to talk about them both. If you know one of them, you basically know them both, because you'll see how similar they are. I like to do both, and I like to think about which one of them I want to use for a specific question, because it will make your life a little bit easier. Okay, so one of them goes like this: sine A over A equals sine B over B equals sine C over C. And what you notice is A always goes with A, B always goes with B, C always goes with C. And what this law says is the sine of the angle divided by the side length across from it is proportional for all three sides in a triangle. So this is the one that I would use for angles if I'm solving for an angle, because the angles are on top. Okay, so I would use that one to solve for angles. The other version is A over sine A equals B over sine B equals C over sine C, and I would use this one if I'm solving for a side length, because that has side lengths on top and it's going to be a little bit easier. You don't have to start with the correct one, but the way that I do it, that's the way I do it, that's the way I show it, and I think it's a fairly simple thing that you'll be able to do, and it will make your life a little bit easier. If you start with the wrong one, the algebra is a little bit trickier. We probably won't look at an example of that, so you may not know what to do, but you're more than welcome to ask if you get stuck, or if you'd just like to see it, okay? But these are the two forms. You can see how similar they are. I can't do A over sine A equals sine B over B. You certainly can't do that, and you don't do sine A over B. You certainly don't do that. So all of those situations would be wrong. I can't crisscross like that, okay? If I have one of the angles on top, all of the angles have to be on top. If I have one side length on top, all side lengths are on top. And we don't use all three for a single question. We're only going to need two, and for an equation you can only use two. So you'll notice when we start setting these up, I won't even write down all three. I'll just write down the two that we're going to use, but this is how we see the formula. We see it with all three, and it does. And what it's just saying is all three are proportional to each other. Before we go ahead and solve some questions, I like to take a moment to just look at the solving and putting it into the calculator. So we're going to look at 4 questions that have already been set up for us, and you can see how, whoops, these look like the equations that we were just looking at. But it's already got one angle put in and 2 side lengths, and B already has 2 angles put in and 1 side length. So it's already got everything substituted and set up, and now we're just going to solve. I'm always going to have, if I do it correctly, I'm always going to have my variable on top, over top of something, and my first step is going to be to take that something and multiply on top on the other side. And you'll do this often enough when you go through the practice that you'll get very used to that. So I took what was on the bottom here and I multiplied by it on the other side. Now I'm solving for an angle, so I'm going to have to do shift with my calculator, and I'm just going to go shift sign and put this whole thing in. But depending on your calculator, it's always going to look a little different, and even more so than SOHCAHTOA did. I talked about the difference between different kinds of calculators in the SOHCAHTOA lessons, but for this, it's even more the case. And we get to one of the examples specifically in cosine can be quite difficult without a good calculator. So it's something to think about before tomorrow. I mean, you can always borrow one of my calculators, but it's good to have your own. And if you get one like this, makes it a lot easier specifically for cosine, which we're going to do tomorrow. Now, I'm using, I'm just going to make a note of this, shift sine, right? And that gives me theta equals, so it might be, you might do it sine -1 of all of this. That's what it kind of looks like in your calculator, possibly, right? So I'll write this out just for this first one. But normally I'm just going to go shift sign equals. So shift sign, hopefully I am in degrees. What's our trick? Cos of 60 is a half, so I am in degrees. So shift sign. It already opened a bracket for me, otherwise I would have to open my own bracket. Okay, and in this case I'm going to go 41 times sine 74. Now again, this calculator opens a bracket, so I have to close that bracket because I only want to do sine of 74 divided by 77. Notice how I do it all together in one shot. And that's 30.78 or 31 degrees. That's how you do it on my calculator. On these ones where you can punch everything in all at once. What if you have one of the other types? Well, I'm going to do 41 times, remember you put the angle in first, so 74 sine equals divided by 77 equals, and then I'm going to do second function sine. So I do everything first and then I hit second function sine, and look at that, 30.7 or 31 degrees. Okay, this calculator is not the best for demonstrating. I know I'm only going to use it twice to do this. You can do it that way with this calculator as well. 41 times sine of 74, except you would put in the 74 first on one of those other calculators, hit equals, divided by 77, hit equals, shift sine equals, and you get your answer. Okay, so it's a little bit of a different order if you don't have a calculator like this. This is the one where we've got 2 angles on bottom. I know they're angles because they have a sign with them, but I still do the same thing where I take the thing on the bottom where the variable is and I multiply it by it on top on the other side. You can never change a sign to a different number like that. So if it's sine of 50, it has to stay sine of 50. If it's sine 81, it has to stay sine of 81. Okay, that's really, really important. Now x equals, I don't need to do shift sign in this case, so I'm going to do 13.1 times sine of 50. Again, I have to close that bracket, divided by sine of 81. I don't have to close this bracket because the question's over, and that is 10.2 because the 6 rounds the 1 up to a 2. Okay. On the other calculator, I would do it like this. Just going to get it where I can see it. I would do 13.1 times, you have to put the angle in first, then hit sine, equals, divided by 81, put the angle in first, then hit sine, and then finally end with equals. And again, I got 10.16, which is 10.2. Okay. That's how you do it on those calculators that don't have two lines where you can't punch all the stuff in all at once. This is where I usually take a break and ask you to try it yourself for C and D, and I walk around and I make sure that people are doing it correct on their calculator. So what I would encourage you to do is pause the video, try this one on your calculator, try to get 31, try this one on your calculator, try to get the 10.16 or 10.2, and then try these two, and then look at my answers and hopefully you get the same thing. But if you're not getting the same thing, you're going to have to go back and watch that again, or find somebody that can help you, or ask me if you get a chance. Okay. And I will walk you through it again, but I'm not going to walk through both calculators every single time. Okay. So it is up to you a little bit to figure out how to use your calculator. They are all a bit different. So you can pause now and try those on your own and make sure that you're getting the right answers. Now I'm going to go ahead and finish these. So the sine 13 is what moves over to the top on the other side. So I get 155 sine 13 over sine 67. So 155 sine 13. If you're using the other calculator, you put the 13 in first, then hit sine, divided by sine of 67. Careful of your brackets. Brackets are going to be a big deal in all of this. And I'm going to round this to 1 decimal place because this is like a side length. I mean, this was set up for us. We didn't set it up, but this would be like a side length because angles are the ones that are with the sine, right? So I know that this would be a side length. And we usually do those ones to 1 decimal. I'm going to rearrange this one. The only thing about this one is the variable's on the wrong side, but that's fine. So I bring the 20 to the top on the other side. I don't change this to sine of 50 or anything like that. Okay, it's still, you can't do that. It's still just 50. The 20 moved is sine theta. So theta equals, and this is the one where I go shift sine, and you get the sine -1. And if you want, you can even use your, if you have a calculator like this, you can use your fraction. 20 sine 40 over 50 equals 14.89 or 15 degrees. Okay, so shift sine 20 times sine 40, close bracket, divided by 50, 15 degrees. So that's how you use your calculator. Being able to use your calculator properly is a big part of sine law and cosine law that we're doing over these 2 days. Hopefully everybody's on the right track and you figured it out. It's worth taking time to make sure you can do it right on your calculator. And a really big part of this is making sure you're always getting the right answer with your calculator, because if it's just a calculator mistake, but you're doing everything else right, your answers are always going to look wrong and you're going to get very frustrated. Okay, solve for the indicated side length or angle, round side lengths to 1 decimal place and angles to the nearest degree. So now this is where we have to set it up for ourselves. So we're going to go through a few different examples of these. Okay, this one I'm looking for a side length. So I'm going to start with this formula, A over sine A equals B over sine B. Now, what I said was capital A and little a go together. So they have to be a side length and the angle, or an angle and the side length across from it, and an angle and the side length across from it. I used A and B again. This triangle is labeled, so maybe you use different labels, and this is up to you. Some people don't like changing the variables around, so it confuses them, but some people might want to. So you could change this to n over sine of n equals L over sine of L, right? But you don't have to, you certainly don't have to write it twice. You don't even have to write it once if you don't want to. The important thing is that X and 36 go together and 61 and 81 go together. That's the most important thing. So I'm going to put X on this side over sine of the angle. It's always sine of an angle. That's a mistake some people make. They put a side length in there, okay? And that's really wrong. You always got to be taking sine of an angle or cos of an angle, or tan of an angle for that matter. Side lengths go on top. I put X, which is a side length, on top, so I have to put 81, which is a side length, on top over sine of 61. So that's the setup. Again, side length and angle, side length and angle. That's what sine law is all about, okay? I picked this version with the side lengths on top because I'm looking for a side length, and that left me with X on top, which is what I want. Now this is like those questions we were just doing, where I do one step to rearrange, and then I can punch it into my calculator. This is a side length, so we're going to round to 1 decimal place, and I get, and I'm not doing shift sine because I'm not looking for an angle, 81 times sine of 36, close bracket, divided by sine of 61. I don't need a close bracket there. I'm going to show you something. Side length, so 54.4, and we have units, so I'm going to include them centimeters. What if I did it as a fraction like this? These calculators tend to be really picky. So in this case, I do need to close the bracket, or it's going to give me an error. Okay, but it gives me the same answer. So that was the full setup, angles and side lengths across from each other. Okay, full setup, rearranging, and punching it into my calculator. What about this one? Well, right off the bat, I see we're looking for an angle. So I'm going to do sine of A over A equals sine B over B. Notice I'm not doing the sine C over C because we don't need it. In fact, it would just be in the way. And what I need to do is I need to look at the side length and angle across from each other. And I would recommend, especially in the start, draw these lines in. Why not? It only takes half a second to do, or circle them. And make sure you're circling them correctly, okay? Because there are situations where it's not quite as straightforward. We're going to see that eventually, okay? So when I circle them like that, I know the theta goes with the 15, so it's sine theta over 15. That's how that works. They go together in the same fraction. And then 75 goes with 17, so sine of 75. How do I know the 75 is on top? Because it's the angle, and I'm always doing sine of an angle, and I started with sine of the angle on the other side. So over 17. One step to rearrange. The 15 moves up to the top on the other side. And this is the one where we have to do shift sine. Shift sine 15 times sine 75, close bracket. People will do all the great work. Everything looks fantastic. They're punching it into their calculator. They forget one little bracket. Watch this. Error. What happened? Okay, I forgot one little bracket. Shift sine 15 times sine 75, close bracket, because I'm only doing sine of 75 divided by 17 equals 58 degrees. Okay, that time it worked, other time error because of brackets. It can be very frustrating, although if you get an error, at least you're not getting an answer to write down and you know something's wrong. And the first thing I would think of, in fact, whenever I do this and I walk around and people will say, I'm getting an error, I'm getting an error, my first answer is, it's probably brackets. You're missing a bracket or you've got an extra bracket or something like that, okay? So try to remember that. If you get an error on your calculator, the first thing to look at is, are you doing brackets, including the closing bracket that you might need? If you have to come back and watch this part of the video for that reminder, do that. Okay, if you can ask somebody for help, if I'm around, you can ask me, that's great. The next thing is you may have set it up wrong. Okay, that's the next thing that I would have to look at. And you just got to remember things like both angles have to be on top. Angles are the things that go with the sine. Both side lengths have to be on the bottom, that kind of a thing. Okay, I believe this is our last example. And there's something that is a little bit different about this one. Okay. And so let's get started and see what happens. Now, I'm looking for an angle. So I'm going to do sine A over A equals sine B over B. Again, this triangle is labeled, but this A, this is going to be a bit strange, is not the same as that A. Not necessarily. Even though that's got the theta there, just give me a second here. Okay, this is a formula that I always use A and B's for. In fact, I used it up here even when I had L, M, and N. I still started with A's and B's. And this is what I was talking about. Some people get confused when you start changing the variables around. But you got to trust me, this A is not the same as that A. It just means any of the angles. Here's the problem. 40 and 18 go together. That looks clear. But when I go across from theta, there is no side length. So I'll tell you something. This is what people would do. Don't write this down. Just watch for a minute. They'd go sine of theta, and they would do this one right. They'd get sine of 40 over 18. Well, I'm going to get that one right because they're across from each other. So they go with each other. So I've got sine of 40 and 18. So sine of, well, that must be over 21, right? Well, no, it's not, because they're not across from each other. The 21 isn't over there. Okay, it's up here. It's across from C. So what does that mean? Does it mean we can't solve this question? No. Trust me, we can solve it. It means this isn't theta. What is across from 21? C. C is across from 21. So that's the only thing that we can find here. We can't find theta, not yet at least. Okay, but if I've given you this question in a worksheet or on a test, it will be solvable. Okay, if you think it's not, you can ask and I'll tell you, no, there's no mistake. It is solvable. There's no tricks that way. This looks like a trick, and it does have an extra step to it, but it's something that pushes our understanding and forces us to remember that the side length and the angles have to go with each other. Okay, and I don't know A, so I can't find theta. So what do I do instead? Well, let's find what we can find. And some of you probably already know where this is going. But once we find angle C, the rest of us might be able to figure out what's happening here as well. So C equals shift sine. Let's do it this way this time. 21 sine 40. Got to close that bracket, over 18 equals 48.5 or 49 degrees. Now, I'm not going to clear that. I'm going to leave that on there, although in this case it's not so important. But that means this is 49 degrees. Well, this is something we've talked about. If this is 40 and this is 49, how do I find theta? So therefore, theta is 180 minus 40 minus 49. Now I've still got, it's not, that 49 was rounded, and I've still got the actual answer on my calculator. So I'm going to use it. And this is something where the other day I talked about exact answers and rounding and that kind of thing. And this is one way that you can avoid rounding, by learning to use the calculator, or the answer that's stored on your calculator. So 180 minus 40 minus, and I'm going to hit this answer key, and that is going to use the last answer stored on the calculator, and it'll be exact. So that equals 91. Now, because I'm just subtracting, that's going to give me the exact same answer as if I had just punched in 49. When I round, okay, 91.4 rounds to 91, but there are situations where using a rounded answer won't give you the same answer. We did see that previously. So if you can use the answer button on your calculator, if your calculator has one, um, at, for the stored answer, now this is different because now my stored answer is 91. So if I use answer, it's just going to be 91. So it's only good for the last answer that's in your calculator, but it's a good way to avoid using a rounded answer. And take a look at that. We found theta. That's what we were trying to find. It had an extra step because the 21 that I was given was across from C, and so I had to find C first. But I could use that to find the theta value that I actually wanted. So that's one of the tricks. And tomorrow we're going to do cosine. Then we're going to look at both of them together. And that's when we're really going to see that sometimes we start to make mistakes, especially in questions like this. So that's what that day where we're choosing the right law will really be all about. It'll be about really hammering home, recognizing when sine law will work and recognizing when cosine will work, and in particular in the tricky case like this where there's a couple of steps to find what you need to find. Okay, but trust me, trust me, trust me, for sine law you always have to be using the angle and the side length across from it. No exceptions. I can never use an angle with any other side length like that. That's why we had to find that first before we could find theta. Okay, and that sine law, again, finding an angle and finding a side are the two different sort of versions with that. There are a couple of cases like this example C where there's a trick to it. Otherwise, it's basically the same. You want to start with the right law. If I'm looking for an angle, I want angles on top. If I'm looking for a side length, I want side lengths on top. I do one step to rearrange, and then you got to know how to put it in your calculator. So those are all the most important things about this. And again, reflecting on whether, like I would say, use all of these examples. These four are good ones to make sure you're consistently putting it in your calculator and getting the same answer as me and not getting errors and that sort of thing. You want to do that first before you move on to the practice yourself. Because if you're doing the practice yourself and you go through it and um, you try all the questions and you keep getting the wrong answer, you keep getting error and you're getting frustrated and you think you're doing it all wrong, where really it's just you're putting it in your calculator wrong. Okay, so use these examples to make sure you can do your calculator first.